So here's our video for lesson 4, dividing polynomials. I had actually already started the video and then it closed out on me, so some things are already written in. So really the rule to remember for dividing polynomials is that when you divide polynomials with the same base, you subtract the exponents. So for number 1 here, since we have x to the 4th over x cubed, we would subtract 4 minus 3 and get 1. You can write x to the 1st or just x. For number 2, we have 2 variables, but it doesn't make a difference. What you do need to remember is that a and b in the denominator both do have an exponent of 1. So when we subtract, we get a to the 4th, b squared. Something to keep in mind is that you can never have a 0 in the denominator. So if you try to divide by 0, you will get an error message. So if that happens, if you get an error like that, chances are you did something like that. So then the question becomes, well, what if subtracting would lead you to a negative exponent? And we do have rules for negative exponents, but we're not going to go over those right yet, because I actually think it's easier to do it in the following way. As long as the exponents that you're dealing with are positive to begin with, it's as simple as looking to see where the exponent is greater, in the numerator or the denominator. So for example, I'll do one off to the side here. If I had x to the 3rd over x to the 5th, okay? If you were to write that out with multiplication, that's supposed to be an x, okay? You would now be able to cancel each x in the top with an x in the bottom. And what you would be left with is 1 over x squared. So we're still subtracting, but instead of doing 3 minus 5, we're doing 5 minus 3. So with something like number 3 here, whenever you have a problem that's a fraction and there's a lot going on, what I start off by doing is simply drawing the line. And very simply, things are either going to end up above the line or below the line. If nothing ends up above the line, you have to fill in a 1. If nothing ends up below the line, you don't have to write anything. Okay, so the first thing we have is negative 28 divided by 7. That will be negative 4, and that would be above the line. If it had been the reverse, like this, then we would have written negative 1 over 4. Okay, now with the a's, we have more a's in the top. 5 minus 1 is 4. What's going to happen to the b's? Well, they're going to cancel completely. And now for the c's, we have more c's in the bottom, so that's where c is going to end up. And 3 minus 2 is 1. So you can write the 1, but you don't have to. Something else to remember is when you have something like b to the 7th over b over 7, if we were to use our rule of exponents to subtract, we would end up with b to the 0. But we already know anything over itself is 1. So what that means is anything to the 0 power is 1. Okay, and our last example, number 4, is kind of similar. I think we went over a few of these with our distributive property. What I would do here is write this as 2 separate fractions. So 48x cubed yz squared over negative 3xyz. And then a second fraction, but obviously with the same denominator. And now you're going to simplify both of them separately. So for the first fraction, I draw my line. 48 divided by negative 3 is negative 16. There are more x's in the top, so 3 minus 1 is 2. The y's cancel. there are more z's in the top, and 2 minus 1 is 1. At that point, I would just erase the line. Your other option is to leave the line and put it over 1, but you shouldn't just have it with a line. That doesn't look right. Then we move on to the second fraction. We have negative 6 divided by negative 3, so plus 2. X squared over x will give us x. Y squared over y will give us y. And the z's cancel. So again, I'll get rid of my line. So my final answer, negative 16x squared z plus 2xy. Remember, these are not like terms. You cannot add an x squared z with an xy. So that would be your final answer. So at this point, you should open the assignment, the homework assignment for the lesson 4 practice problems.